So now that you've performed some assembly line balancing, uh, you have allocated each of the tasks that are needed to produce a good or provide a service, and you have allocated them to different workstations or areas within our facility. And you did so in order to make sure that there were equal time requirements at each workstation. So this really assumed that we knew exactly how long it took to do each task. And if you recall in the example, we gave you an exact time for each of the tasks. But what if there's variability in the task time? What if some days it takes you more time or less time? And in the example, we were building a table. So what if, attaching one of the legs takes longer than anticipated? What do you do about it? Well, if there's variability in the task time, then we need to make sure we leave idle time in the workstations. So in the assembly line balancing, we were trying to minimize the idle time and increase our efficiency. But if you have a lot of variability in your task time, you're going to need to build in a buffer. And that buffer is a time buffer. You're going to have to add a little bit extra time at each workstation just in case a task takes longer than you think. So if there's variability, you want to leave idle time at each workstation. There are other things you can do as well. You can look at, is there some extra inventory, some work in process that can be sitting at your workstation so that if you're waiting on a different workstation for materials because it's taking longer than you thought, there's something to work on. Or maybe you can find ways to reduce variability by designing the process better, increasing the quality of material, doing preventative maintenance. So once you've really reduced the variability as much as you can, then the other key is to leave some idle time. And so it's a bit of a compromise because you don't want to leave too much idle time because then your efficiency drops. At the same time, if there's variability in your task, you're going to need a bit of idle time to allow for that. So how do you increase the idle time without increasing or decreasing the efficiency too much? And that's a decision you have to make as an operations manager. The other thing you have to look at when you're doing assembly line balancing is the role of the bottleneck in your process. The bottleneck, of course, is the activity that takes the longest, and so, of course, is limiting your ability to get your project done. And so when we look at bottlenecks, we need to think about using parallel processing. In this example here, let's assume that the first activity in our production line takes 1 minute. Well, if it takes 1 minute to do, we should be able to get 60 per hour through activity 1. And when we look at activity 2, it also takes 1 minute, so we should be able to get 60 units per hour through it as well. But when we get to activity 3, it's the bottleneck. It takes 2 minutes, and so we're only able to get 30 units through per hour. Since the bottleneck sets the capacity and it sets the pace of production, then we're limited by the bottleneck. So really, even though activity 1 and activity 2 can process 60 units per hour, we really should only be processing 30 per hour because otherwise they're just going to end up stockpiled here outside of the bottleneck. And last thing we want is all our work in process to start piling up in front of the bottleneck. So we're actually limited to 30 units per hour because that's the max the bottleneck can do. Well, if your activity or your activities or your steps in your production process allow for more production, one way to deal with the bottleneck is to use what is called parallel processing. So the idea is activity 1 and activity 2 can produce at 60 units per hour, and then we have 2 of the bottleneck so that if they each produce 2 minutes a unit, so we can do 30 per hour, then we don't slow down production because activity 1 and 2 are producing 60 per hour, and then half of those go to workstation or activity 3A, and the other half go to 3B. And so this means that you can continue producing at 60 units per hour without being limited by that bottleneck. So one way to address the issue of the bottleneck is to have more than one of them in what we call parallel processing.